Everybody got about a good idea, or are you still thinking?
We just rewrite on here.
No, it's just on here, and then we'll vote. So who thinks it's A? Who thinks it's B?
Wait a minute, no. Are you saying, so is A saying that a penguin would eat the seal and a shark would eat the penguin?
No, it's saying of that food web listed, which ones are the top predators for that food web of the options that you have listed on your choices?
Okay, I pick A.
Okay. How about B?
Well, those two
C?
are small, so.
D? Okay. So why did you pick C?
Because there's a lot more phytoplankton, like krill and plankton. So I was trying to think of like actual number-wise.
Mm-hmm.
Like clams could consume a lot more krill. Krill could consume like infinitely more,
Okay.
more phytoplankton than,
You picked A. Why did you pick A?
Because sharks just seem like they would be the highest level, you know?
You picked D. Why did you pick D?
It was between A and D, and I just decided that a penguin just doesn't seem very ferocious. I don't even know if it's a carnivore. I would assume it is. I don't know. So I picked D.
They eat fish.
That's
Oh.
fish.
So the correct answer for this one is actually A. Because seals, penguins, and sharks are the top carnivores for this food web in particular. Penguins do eat fish. So,
After I said that, I realized they do. Sharks eat penguins.
and so yes, see, they do eat the most. They are the most massive part of the food web, but they're not the top carnivore. So when you hear the word food web or the phrase food web, what do you think of?
What eats what?
Spiderweb with mosquitoes in it.
I think of food chain.
So food chain is close. And so like a spider web, a food web is something that's interconnected. And so when I say, think of web, you think of something that's interconnected kind of thing. So when I say food, what do you think of?
Hungry right now. Really, really hungry.
So something you eat.
Yeah.
So would you say it's, something that gives you energy to keep you going through the day?
Mm-hmm.
So food webs are something that's an interconnected flow of energy. And you could kind of observe a food chain in your backyard, right? So that's what a good idea for a food web is. So let me go over the objectives. So identification of the feeding relationships of animals in an ecosystem. And to trace the flow of energy and nutrients through an ecosystem. Understanding how organisms in an ecosystem are interrelated, and understanding the complex and dynamic nature of an ecosystem. So now that we have talked about a food web, you mentioned food chains. So what do you think a food chain is?
For example, like a mice is eaten by a snake, and an owl is eaten, or a snake is eaten by an owl.
Mm-hmm.
It's like a chain. It's like just a constant chain of what eats what.
So would you consider it more singular, or do you think it's like the web and interconnected?
It's more singular.
Okay. And that's really what it is. It's the food web shows all the different flow in an entire ecosystem because it's looking at how the energy flows, whereas a food chain is just looking at one simple thing. Like it looks just at the energy through that one chain is basically what it is. So I have a couple of slides to show you, just examples. So here is, we looked at the ocean one. Here's a forest one. As you see, the rabbit has, it has the grass, but then it also has the predators of the hawk and the fox. So there's two different lines going from the rabbit. That's what makes this a web, because you have the two separate lines coming from the rabbit. And then if you look at the mouse, it also has two separate lines coming from it. As you look at the arrows, please notice that the arrowheads are going to what is eating the resource, because the lines are drawn how energy flows through the web. So the energy is going from the rabbit to the hawk, or from the rabbit to the fox. So ecosystems they're dynamic. So it's going to shift, it's going to have different changes in it throughout. Please notice again that the arrows do point as it goes up, following the energy. So here is a food chain, again, showing you the arrows, and this is a smaller food chain. It's more with bugs, and then, or food web. And here is a food chain showing you the singular columns and how a food chain looks. Notice it has the arrows pointing towards the top consumer following the energy flow. So as consumers eat the lower resources, how much energy do you think goes from, like, say, the plant to the mouse? How much energy do you think they get from that plant? Okay, so what if something came along and ate the mouse? How much energy, percentage-wise, how much do you think they would get from that mouse? So they actually only get 10% from each thing. So if you have like a large grassland that is like 10,000 kilocalories, the mouse would only theoretically get 1,000 kilocalories from the grass. And then whatever ate the mouse, say like a hawk ate the mouse, then they would only get 10 kilocalories from the grass. Because each level, it dropped, they only get 10% of each level. So, and the reason there's so little transfer is because that, yes, they're getting all of that, but so much is getting lost in the metabolism and being put out through heat. So the energy itself is not like just going, into the universe kind of thing. It is as far as heat production, but they're not getting to use it as far as energy for themselves. So I have a slide to talk about that. So, and as you see, you're definitely going to have more of your bottom and less of your top, because since there's less going up, less energy going up each level, you're not going to be able to sustain, they're not going to have as many predators because there just won't be as much kind of thing. So, what do you think happens if you end up having a lot of carnivores in an ecosystem? Right. So if you've got a top part that's really heavy, that means your middle level is going to be lower. What do you think that's going to do to the bottom level? Well, if you don't have a lot of something eating the bottom level, so do you, right. Yes. So it's going to be a top down, because you're going to have a really big top, a small base, and then a small middle, and then a big base. So you're going to have a lot of grass, not as many mice, and then a lot of owls. So what do you think happens if instead of having the top increase, we had the bottom increase? We had a lot more grass. What do you think would happen?
More mice.
Right. And if we have more mice, we have more? Yes. Yes. So, and this just shows you that small changes in an ecosystem can have really big effects. So a lot of hunting of the top animal means that the bottom ones are going to get bigger. This was seen in Yellowstone with the predators that were reduced. Then there was so many elk that, it was hurting all the plants that were there. And so they had to reintroduce predators to get the levels back down. So small changes really do affect the ecosystem. Like, people don't, it's dynamic. It's always shifting, it's always changing. It's never one static thing, and it always stays like that. So now we have the activity, the sheet that's in front of you. I want you to look through it and label what you think is a carnivore, herbivore, and omnivore. And then also label what you think is a producer, a primary consumer, a secondary consumer, or a tertiary consumer. Basically, a primary is the first one, like, say, something that eats grass kind of thing. A secondary would be what eats the primary. quaternary would be what eats the secondary, and then the tertiary is what eats the secondary, and then quaternary is at the very top, like the apex predator. The one down at the bottom is a worm. The one at the top is a snake. And then after you've gotten the front side done, you can flip it over, and as you see at the bottom, it gives you instructions to write different animals, and you can then draw in the arrows with the correct orientation to how the food web would work in the ecosystem. Yes?
So with energy loss, as part of this, like the drop off and all that, does that mean like if I eat like a handful of grass, I would get more energy than like a handful of owl?
Unfortunately, it doesn't work. I mean, theoretically it would, but was that time? Oh, sorry. Theoretically, yes, but we cannot digest grass. That's why cows, they have to constantly go back into it because they have the mechanical breakdown of the grass. You wouldn't be able to metabolize the grass, so no, you would not get the right kind of energy from it.
Think on your toes.
Okay, so good evening, class. My name is Miss L. My last name is Leverett. A lot of people don't know how to say my last name, so we go by Miss L. Okay, so this is going to be our agenda today. First thing is going to be picture time. Okay, so I'm going to give you a card, and you're going to have to figure out what this picture is saying. I have the words on there already, but you have to put it in the correct order. Okay, so everybody's going to have a card. You're going to work together, and once you decide which way your words are going to be and which one is the beginning, which one's the end, and put the words in between, just put them up here. And well, actually, I guess so we can see them, put them right here. So you'll put your cards here. Okay, so I'm going to give you one. You're going to work together first. You might want to work together at this table to get the complete sentence.
So they're all different.
They're all different, yes. Here you go.
Oh, sorry.
It's okay. I might have to give you more because some reason I thought it was 8 of you all. Okay. And there you go.
Okay.
Now you're looking at the picture and then you're coming up with what you think the phrase may be. And you're going to stick it over there.
The hotline is gonna blink. Hotline. Does anybody blink?
No, that's not what it is.
Okay.
Or
The
dial.
hotline.
Wait, if we look at the back of them, is it cheating?
No. You have a number on the back intentionally. There's a number on the back intentionally.
To me, cells and
I've got direct messenger.
Facebook, contact, or dial. What's yours? Me.
Contact,
Contact me.
contact, no, via,
Via
Facebook.
cell,
hotline, direct messenger.
or dial.
Yeah.
Where are the
Wait,
Okay?
wait.
So transfer them here from the beginning to the end.
Oh wait. It's supposed to be the picture?
Similar to the picture.
Imitate the picture.
Your
Oh.
statement is going to be the
So
picture.
it's Facebook, then email,
Mm,
then cell phone.
I'm not saying that. I think you might have been right. Oh, no. Yeah, no, something is out of order.
Direct messenger.
Those are right.
Then
contact or dial. Oh, never mind.
direct messenger. What's hotline?
Now you have 2 that's out of place.
Okay. Contact me via Facebook.
Direct messenger,
Facebook direct messenger.
and then you need to fix your last one is right.
So-
Yes.
email?
No, this was your direct message. This is for your Instagram, your direct messenger box. Facebook direct messenger, hotline.
What's
cell.
a hotline?
Okay, so thank you guys, I really appreciate it. What we're gonna be talking about today are physical properties of matter. This is the actual phrase we're gonna use. Contact me via Facebook, direct messenger, hotline, cell, or dial. So the very first one, contact, that's going to be your color. Okay? So that physical properties of matter are the things that you can see, your 5 senses. Do we know what our senses are? Any volunteers? For what? Okay?
Smell, taste, hearing, sight, and touch.
Okay, so most times in chemistry, I don't want you all to taste anything. So, but those are your 5 senses. So the first one is contact me. Contact is color. Me is malleable. Via is viscosity, which we'll talk about. Then the F is freezing. The capital B is boiling point. The D is density. The M is melting point. Hot line is the H is for hardness. Conductivity. And then your last one is ductility, okay? So this is a phrase that we're going to be using. And I'm going to go ahead and give you this paper because as I go through the PowerPoint, I want you to fill out your paper. And are any of you all familiar with Kahoot? Okay, we're going to do that again today. Yes. Go. Go. I do apologize. I forgot my clicker, but we're going to do it this way. Okay? So matter is anything that has a mass and occupies space. Anything that has mass and occupies space. Matter can be invisible to the eye. Okay? So you might not see it. So matter has to be 2 things. What are the 2 things it has to be? What are the 2 things it has to have?
Mass and it has to occupy space.
Okay, so you might want to fill that in on your paper.
Got it. Boom.
Okay? So physical properties of matter, characteristics of substance that can be observed without changing it. So we're not changing it at all. We're not going to change it. The identity of the substance. All the senses are used, as we talked about before. Okay? So we have color, we have shape, we have size, you have texture, because if you want to feel. Do you have to change an object's identity to see a physical property? First question, do you have to change it to see it? I could visibly see that if you went in and you cut your hair tomorrow, you came into class, or you cut your hair today, you came into class, I would know that you cut your hair. But your hair is still your hair, right? Okay? So do you have to change your object's identity to see the physical property? No. Well, no. So why wouldn't we have to change it?
Because it still has the same properties.
Yes. Good job. Still has the same properties. First one, malleability. It's able to be rolled or pounded. In my case, I have a lot of siblings. As you see, I broke my finger because we were rolling and pounding each other, horse playing, okay? So malleability, keep in mind you're able to mold it in some shape. Okay, you have a matching section, so you want to match your word with the phrase that's there. Yes. So we already did color, we did malleability, so we contact me, via, which would be viscosity. Does anybody know what viscosity might mean?
I like stickiness.
It is like stickiness, yes. Okay, so it's the tendency of a liquid to resist flowing. High viscosity, it flows slow, like cough syrup. Low viscosity, it flows quickly. So what would be something that we eat a lot, if you like IHOP, that has a high viscosity? Syrup. Good job. Or cheese dip, yeah, cheese dip will work. Cheese dip will work. Okay, now we're at Facebook, freezing point. The temperature when a liquid becomes a solid. Okay? Boiling point, the temperature when a liquid becomes a gas. Do we know the freezing point of water? What would it be?
32 degrees Fahrenheit.
Yes, anytime we can get out of school, there's freezing. We're freezing point of water, we're looking for snow. What about the boiling point of water?
Is it 100?
Higher.
132.
Keep going.
145.
Keep going.
150.
A little bit lower than 216. 212. 212.
I like that.
He reached in.
I like that.
And Celsius boiling
Yeah.
is 100. And then so freezing in Celsius would be what? 0. Another measurement that we have, just to see if we know, kelvins. What is the freezing point of water in kelvins? Anybody happen to know? Yes, for freezing, 273. Good job. Good job. Okay, so now we're talking about density. Okay, so that's going to be your heaviness. It's basically what it is, your heaviness. But it's the measure of mass, amount of mass in a given amount of volume. Have you ever heard, because I heard I have math students today, have you ever heard density, the formula is like a broken heart? No? Okay, let's see if you see it.
It is a broken heart.
So we'll know it's mass over volume. Okay? The temperature of a solid, melting point is the temperature when a solid becomes a liquid. As you see here, we're talking about ice. So in this picture, if I'm telling you this is your homemade vinaigrette dressing, you have oil and vinegar. If I'm telling you this bottom is your vinegar, what would you say about its density? And the top is oil.
It's more dense than oil.
Yes, good job. Okay, so we're talking about conductivity, transmission of energy. Most cases, we're talking about these two types, electrical, as you see. I have a little illustration up here for you. And then you have thermal. And now in our statement, we are at, yes, thank you. Thank you. Yes, we're at cell. So you have a conductivity. Please fill in on your paper as well. This will be your study guide. Hint, 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 I give pop quizzes. You'll do fine, you'll do fine. Okay, and the last one, ductility. Ductility is able to be pulled or stretched. Just think about when you're playing tug of war. You're able to pull and stretch the other team to your side, okay? And then does an object lose its strength though? In this picture, it is copper wire. Does it lose its strength as it's being stretched or pulled? Keep in mind, these are physical properties. And the identity does not change. So if you were strong to begin with, and we still strong. See, I got it. Okay, so physical property of matter. Here's our original picture. Had to do in black and white. This is our original picture. If you pull out your electronic device, whether you have a phone, tablet, or whatever, if you could Google Kahoot, which it is Kahoot, so we can play our game. 1 minute. Okay, good. We can do this in 1 minute. This will work. Okay, and once you open it up, this is the code. I usually have silence, I don't have speakers. So this is the code you're gonna put in. Put in your name, whatever name you wanna go by. It doesn't have to be your real name. I usually don't put my real name just in case I get questions wrong. Okay, so you're gonna put in your PIN. Okay, got one in already. Anybody else in?
Got it.
Got it?
Awesome sauce, Mom. That's God.
And everybody else coming in?
Ooh, looks like it's just me and Scott.
Going down.
As we, the pin is going to be up there, so as we go through, you can still join, okay? Keep in mind, whoever answers first is a competition, so you get more points, even if you get the correct answer. So, are we ready?
Yes.
Ah.
Okay, so on the screen, on my right, your left, I have a picture of, yes, that is my niece and nephew. They're about a week old. On the, well, my left, your right, that is their parents. My question for you guys is, how do we go from being little babies to being grown-up adults? Does anyone have any ideas? Yeah, Logan.
Mitosis.
Okay. Yeah. Okay. What is mitosis?
Back when the cells split.
Okay. So it's cell division, which creates more cells, which causes us to grow. That's good. Okay. How many of you have ever had a cut or a scrape before? Just show your hand. Okay. So everybody. How come you can no longer see your cut or your scrape? It healed over. Okay, so
So your body regenerated cells that it lost. So it just created more to replace the ones that got taken off when you got cut or scraped. So we grow, our cells divide, get created. You guys kind of jumped ahead of me with the mitosis. One of my questions was going to be, how do more cells just appear? Like, how do we get more cells? But you guys answered that when you said cell division or mitosis. So you have a cell cycle. This is how our cells grow. The cell cycle can be broken down into 3 different stages. You have interphase, which is just the growing and the preparation part of the cell cycle, and that gets it ready to go into mitosis and for the cell to divide. And then you have cytokinesis. This happens at the end of mitosis to actually finish breaking the cells into 2 individual ones. Yes?
What's the difference between interphase and mitosis? Because I thought they were just both floating in mitosis.
We're going to go into detail in interphase, and you'll see how it affects mitosis. Yes?
Are we going to discuss the difference between mitosis and meiosis, or are they the same thing?
Not in this class. They're different things. Mitosis is the cell division in non-sex cells, and meiosis is the cell division in the cells that eventually come together to make human embryos. So your sperm cells and your egg cells. So interphase has 3 different phases to it. You have your G1 phase, your S phase, and your G2 phase. Your G1 and your G2 phases are called gap phases. This is where you have cell growth, and it's where your cells are copying their organelles to get ready to go into this division, so that when the cells divide, you have an equal amount of organelles in both cells. So it's not the actual division, it's just the getting everything ready for the division.
Are organelles the stuff in it?
Yeah, organelles are the things inside the cells. So it's anything from the Golgi apparatus, the mitochondria, the powerhouse of the cell, all this stuff that we've learned about in previous classes. Those are the organelles. So we go through this cycle, create more cells, and during the growth phases, the G1 and the G2, sometimes cells can go into what we call the G0 phase, and it's just cells resting and preparing, or they're not preparing to divide, they're just sort of hanging out until they need to divide and until they need to grow to get ready. In the S phase, we call it the synthesis phase, is when the DNA replicates. So in your cells, you have chromosomes in the nucleus, and packaged inside your chromosomes is DNA. And synthesis is just DNA replicating so that when it goes to divide again, you have an equal number of chromosomes in both cells and the same amount of genetic material in both of the cells. Now, I've just given you guys kind of a lot of information. So can anyone sort of tell me or remind me what the 3 different stages of the cell cycle are? Yeah, Logan.
The first one is interphase.
Okay.
The second one is mitosis/meiosis.
Okay.
And then the last one,
The mind reading one.
oh yeah.
Cytokinesis. Good job.
Kinesis.
Close. You got the kinesis part right. Okay. From those 3 phases, does everyone remember which phase does what for the cell?
Well, the G's are like where
In the cell cycle.
so they just grow.
Okay, what do the first 2 do?
The first one is when it's like growing and preparing to split.
Okay, that's interphase.
Right. And
Okay.
then the second one is
So that's mitosis or meiosis. That's when it's actually going through creating a way for the genetic material to go into both cells. And then, does anyone remember what happens with cytokinesis?
Is it when like the cytoplasm?
Yeah, exactly. The cytoplasm finishes dividing and you get that cleavage furrow, and then it closes off and you get two separate cells. Good job, guys.
So what kind of looks like some kidney beans and just like flows kind of like.
Yeah, they kind of. So, you guys said you learned about mitosis earlier.
Well, not like that.
Well, this is the telophase part of the cell, and so when you finish dividing, your cytoplasm splits. We call this a cleavage furrow, this part, and then when they finally split and become two separate cells, cytokinesis causes that.
So is telophase in between mitosis and cytokinesis?
Yes, telophase is the last part of
So
mitosis.
it is mitosis.
Yes.
Okay.
Yes. Good job. Okay. And then what were the three phases of interphase again? The what? Blank, blank, blank phase.
Oh, G1, G2.
Okay. And then what happens in G1 and G2?
Those are gap
Cells
phases.
grow.
Yeah.
It's growing.
It's growing. And what else happens during the G1 and G2?
Protein is developed and
You like
Protein?
copy all
It
the
like
things out.
duplicates everything.
Duplicates the organelles. Not everything,
Not everything.
just the organelles. You get duplication of DNA or replication in the S phase. Synthesis, exactly. You guys know this. Okay, so I told you guys what the phases are and what happens. One thing I didn't mention is time. How long do you think it takes for a cell to go through interphase and to divide? Seconds. Any other guesses?
Maybe like
I
10.
heard you get like a new
It's
body
like
every 6
1
weeks.
Yeah. So if it takes like a day.
But does it take 6 weeks or does it like wait and then
Or like
like
parts throughout.
in 10 seconds it like splits?
Okay, so we have seconds, we have weeks, we have
I'm
minutes.
thinking about 2 hours.
Okay, so those are all good guesses, and you're all right. It depends on the cell and the organism for how long it takes for the cell to actually go through interphase.
Which one does it the fastest? Do you know?
I don't know which one does it the fastest, like out of the whole world, but in our body we have rapidly dividing cells, which will be like your skin cells, your hair cells, stuff that is always being regenerated because you get dead skin cells and they fall off. But something that can take years to divide would be something like your liver cell. You don't always need to be dividing your liver cells because you don't always need to be replenishing them. You so the liver cells just sit in that G0 phase for a while until it's ready to go into mitosis and start dividing again. Yes.
So if someone were to have like a liver transplant, so if they were to give part of their liver to someone else, is that when they would start to split and grow and develop? Because your liver grows back, right?
Your liver won't grow back. You would have to get a new one put in. Or you would have to get a stimulus to tell your cells that they need to grow. Does that make sense?
So like when they do like when like you need a new liver and like someone gives you like half of their liver, you have to be on like medicine that tells it to grow.
Yeah,
And then it'll grow, but it won't just like happen on its own.
on a liver transplant, there are a few different things that happen. It's really different. You have to have medicine in your body that's telling your body not to reject the other liver cells because that liver cell's DNA is not going to match your DNA, and our body's going to try and fight that off and say that that's an infection. So that's one of the things that has to happen. Yeah.
Like you're the same blood type, you can do that. Never my thought.
Not always. It can still fight it off just because of immune cells in your immune system. And that's something that we can talk about in a later point in time. You guys, that's really all I have. So I was gonna have you do a closing exercise if we had time, but
Do it.
I mean, does anyone? So I had a picture on one of the slides of like the cycle of interphase. Does anyone think they could draw it? Yeah. Okay.
You got this?
I'm not gonna label it though.
Don't label it. We don't like labels.
We can label it together.
Labeling is judgmental, right?
What's happening?
Well, you got a Pac-Man pizza,
Okay.
then you have a bigger pizza with no Pac-Man.
But there were arrows on that.
Yeah, there's
Right.
arrows throughout the whole thing.
Or is it a lesson?
Is this what we're drawing?
I don't know. It's a
Or
Pac-Man
are you
pizza because
telling
I'm
us
in the
to
mood
draw
for pizza.
like when it's
Okay.
split?
Okay. So what is happening in this part right here? Cytokinesis and mitosis. Okay.
Wait, what about
So-
the rest of it? I'm interested.
Okay.
G1,
So
S,
here
G2.
and here. So what's happening here?
G1.
G1.
Then S.
S.
Wait, it
S.
all happens at the
G2.
same time? It's not like phases?
It is in phases.
Oh, it is in phases.
This will happen, then the
So like-
synthesis,
so like
and then
the-
that.
Okay. I like
Yeah.
this. Good job.
All right, everybody. So today we are going to be practicing with our conversions, and then we're actually going to be defining a new unit for our conversions. So we're going to start with an activity. So there's a candy company that wants to give out samples at an event, and they've decided that for each of these samples, they are going to have a malt of candy in each sample, and a malt is just a unit that they came up with. So what I'm going to do is give each of you a set of samples, and I need you to pair up and determine what the best definition for a malt would be based on these samples and the information that I'm giving you about them.
So each bag is a malt?
Yes, each bag contains one malt of candy. So Bethany, if you could work with Logan, actually. And you're going to have 3 minutes to discuss this and come up with your answer. Mhm.
Do we get to eat it afterwards?
Yes.
Do we
Mhm.
raise our hand?
One moment.
Wasn't
Okay.
calories on them?
No, you're so you're supposed to be figuring out what a malt is equal to, and so
I got it.
it could be based on this, or it could be based on something else about these groups.
So like there's 1, 2, 3, 4, 5, 6, 7, 8 gobstoppers.
So
Yes, there are.
People, aren't they?
so is this
So
What do you want to classify as
so keep in mind that it doesn't just have to be based on this chart. It could be based on the bags.
Oh my gosh, there are 8 in all 3 bags.
Is a malt 8? 8?
Okay, so it sounds like most people have got it. So we're gonna go ahead and discuss. So, what did you say a malt was?
8 units of candy.
Yes. So how did you come up with that answer? Why would a malt be 8?
Because you said each of the bags was a malt, and there are 8 candies in each bag, and I couldn't figure out any other way that they connected other than the number.
All right. So what you're saying is that that 8 kind of unifies all of the groups and says that this is how they're all similar, and we can use that similarity to talk about other things. So she is correct. There are 8 objects in a malt. So did anyone else get a different answer, or is anyone not clear on why a malt is 8 pieces of candy? Yes, Logan.
So it has nothing to do with the mass
No.
or the calories.
So that's what I'm saying. Like, it could have been based on that chart, or it could be based on what's in the bags. And so we're just looking for something about these groups that unifies all of them. And if you counted the candies, they all had 8 pieces of candy. Yes, Scott.
So it's not always 8, just this time it's 8.
Well, for one malt, it's 8. That is how we're.
Just have 8 things in it?
Yes.
we are,
No matter what we're talking about, it's always 8.
yes, so we are defining one malt here as 8 pieces of candy, or 8 of anything, so 8 objects. Yes, Emily?
So like, if you had like 8, like giant Snicker bars, like the 1 pound,
Mhm.
that would be a malt.
That would still be a malt.
Even like 8, like the mini ones would be a malt.
Mm-hmm. So, I like where she was going with that. So with this, we had 5 malts of oranges. How many oranges would we have? 40. Mm-hmm. And if we had, let's see, if we had 33 malts of water molecules, how many water molecules would we have?
33 times 8.
How many?
33 times 8.
Well, what is 33 times 8?
264.
Good job, Amanda.
Is it
Now, how did we get from here to here?
times 8?
Times 8 what?
8 objects. 8. Just 8. Yeah.
And, but then look at this. If we just do that, then we get 264 malts
Malt objects.
times unit, or times objects.
Malt objects.
So what else do we need here? What are we missing?
We need to divide by number of malts.
There we go.
Objects per malt.
So it's per 1 malt, which means our units will cancel out and leave us just with our objects.
So the units are objects?
Yes.
So, like, up top?
Units, objects,
Okay, so it's just interchangeable.
yes.
Okay.
And so looking at this, we can also go the other way and say we have a certain number of objects, how many malts do we have? So if we had 32 of an object, how many malts would we have?
4.
Or, let's see. And if we had 344 iron atoms, how many malts of atoms would we have?
43.
Yeah, what she said.
So, once again, how did we get from 344 to, well, 344 objects to 43 malts?
When you multiply it times the same thing you did over there.
You divided? No.
So, here.
So it'd be
So,
one
say,
malt
what were you saying?
divided by 8 objects.
Well, you can multiply.
Oh,
times
but it
the
would be,
What?
it,
Can you say what you
multiply times like a fraction like that, both under 1.
So, what Scott is saying is we're dividing by 8 objects per 1 malt, which is a fraction, and so whenever we are dividing with fractions, then we multiply by the reciprocal.
is there ever a time where, never mind.
Okay.
I answered my question.
All right. So, we have, in chemistry, we have a very special measurement similar to this, but it's a little bit bigger. So, it's called a mole, and it is equal to this many objects.
That's not a little bit bigger.
That's a lot.
Who uses this number?
Why?
No.
Can you tell us what that number is?
Okay, I cannot actually say what that number is. I am not that skilled. So, when we have numbers this big, I don't want to write that number every time, do you?
Nope.
So how do we work with numbers that are like this, where we have numbers down here, but then we have a bunch of zeros? What'd you say, Amanda? So, can you tell me how we'd write this in scientific notation?
Oh, shoot. Hold on, let me count.
6.02 times
6.02?
2, I didn't see the.
There we go.
Times 10 to the
How many zeros are there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20. There's 23. So times 10 to the 20th?
Well, to the 20th would put our this here.
Oh, yeah.
So got to add those other 3 decimals.
23rd.
So times 10 to the 23rd. So if we had this many people, then that would be about 8.6 times the world's population right now. That's a ton. Emily, yes. How I did what? Okay. So what we're saying is if we had the number 6.022, we would have to multiply it by 10 23 times to get this long number.
Is there 23 zeros?
There are 20 zeros, but then there's these other 3 places. So we have to make sure that we're accounting for where our decimal is and the number we're multiplying. Yes, sir.
Could you also say like 6,022, but then you can change it to 20 instead of 23?
Yes, you could.
You don't have to, then you can just count the zeros.
You can do that. It's an equivalent measurement, but just kind of as a convention, we generally put the decimal point after the first number. So, can anyone think of why we would need such a big number to talk about the things we talk about in chemistry? Amanda?
Because we're tiny?
Yes. So, what kinds of things do we generally talk about? Logan? Atoms. So, if you think about an atom is the smallest piece of our universe or of any element that that has all of the properties of that element. So it's really, 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 really tiny. So if you think about this, all the measurements that we've defined already measure things that are our size. They're things that we can hold. They're things that we can see with our own eyes. So if we're going to talk about something that's really small, then we have to have a lot of it in order to measure it with the units that we've already defined. So with that, why would we want to have this one thing that tells us that we have the same amount of all of these different elements? Why would we want to have a unit that kind of unifies all of the different elements that we have? So we say that 1 mole, we have the same number of carbon atoms in 1 mole as we have number of iron atoms. Exactly. So with that, we'll think about our periodic table. What things could we connect this to with our periodic table? Is there a measurement that we're generally given that we'd want to? Mass. So if you think about on the periodic table, we're given this 12.011 on the periodic table. Well, that's actually the mass of one, if you do it in grams, it's the mass of 1 mole of carbon atoms. And the same for all of the masses we're given on the periodic table, that would be the mass of 1 mole of whatever that element is. And then with that, we can start comparing the amounts of elements we have and saying, well, if we have this mass of something in one side of our chemical equation, how will that relate to something on the other side of the chemical equation? And we will talk about that next time.